Okay, welcome back to your last review for precalc. So this is the review for the final for first semester, and I have a rational functions review up here. There's actually two parts of this. There's rational functions, and then the second part is basically where you solve rational functions. Like on this, we were mostly graphing them. So this covers two chapters, rational functions, and then the solving of rational functions. All right, so I hope that you found these notes and that you're going to take some notes for yourself so that you can use that to study right before the actual final. Check it against the answer key that's posted too. All right, so here we go. On this first one, I'm thinking, well, do you know what this even looks like? I hope you remember that rational functions generally looked like this. And they had asymptotes that were there and there, vertical and horizontal asymptotes. And this one was moved. It's moved 2 to the left and down 4. All right, so generally speaking, it looks like this, and then it's moved to the left and down. But boy, that is really hard to actually do in practice. So I think what would be best is if you made an XY chart and you figured out the vertical and the horizontal asymptotes. So this is specifically in the directions here talking about the end behavior and the behavior as the graph approaches the vertical asymptotes. And they want limit notation. Okay, so that's going to happen down here. We'll do our limits down here. All right, so first off, I would make an XY chart. And my vertical asymptote is what makes the denominator 0. So down there, I can see that x equals -2 would make the denominator 0. So that's an important spot. -2 gives me an A, an asymptote. So here's my -2 vertical asymptote. Okay. Now, the other part is the horizontal asymptote. And the horizontal asymptote, to get those, you're thinking about the horizontal one is the one where you put in 1,000 and you try to figure out, like, is there a spot where this graph will kind of level off somewhere? Like, you know, there's an asymptote up there somewhere. So here's how you'd find that one. If you put in 1,000, you'd have 1 over 1,000 plus 2, which is pretty much 1,000. And 1 over 1,000 is pretty much 0. So your final answer would be y equals -4. So that means this asymptote is at down 4 right here. There's an asymptote, the horizontal asymptote. Y equals -4. And the vertical one again was at -2, so that's x equals -2. Okay, now if I want to generally know where my graph is, it's generally going to be in here, but I need to be more specific when I'm actually graphing one of these. So I go on either side of the asymptote and I pick a number, like for instance, -1 and -3. So if I put in -1 into this function, let me clean it up here a little bit. If I put in -1, then that would go right here. And I'd have 1 over 1, which is 1. 1 minus 4 to finish it off here with this -4. 1 minus 4 is -3. So 1, -3 is a point on my graph. If I go over 1 and down 3, that's right there. Okay, now let's try -3. If I put in -3 on this graph, then that's 1 over -1, which makes -1, minus 4, which makes -5. So now I go to -1, 2, 3, 1, 2, 3, 4. There. Oh, wait. I bet some of you were like, wait, he's doing that wrong. You were right, I was graphing it in the wrong spot. -1, -3 is actually 1 to the left and then down 3. So that's right there. And the other one I just graphed, -3, -5 is right there. And so now, there we go. And there is my graph. Okay, now because we care about you guys so much, we've also included a question about writing the limits as you approach those asymptotes. So a reminder of how you do that. Well, first of all, it's lim of f of x as x approaches, and that's how you will start every single limit you ever do. Now, if we're going to go left, now this says left end behavior, so I'm looking for the left end. I'm not doing the asymptote right this second. This is just left end. I'll do the left side of the asymptote in a sec. Left end is right there. So x is approaching negative infinity. It's going way to the left. And here you could say it equals -4. Because that's the line that you're headed towards is -4. Now it's infinities that we're kind of special, weird about, like we only say arrow towards infinity, but for a number you can say it's equal. All right, so when we go way to the left, which is like way out here, the x will become negative infinity and the y will settle in at about -4. All right, so let's try the right end limit. Same lim of f of x as x approaches, and if you're going to the right, it's this part here, that would mean I'm going to go way to towards infinity, and then that doesn't go towards an infinity. That gets, the y is going to get closer and closer to -4 again. All right, next we're going to do this part called left of the vertical asymptote. That'd be right here. That is on the left side of the vertical asymptote. And so I would start with lim of the function as x approaches, and this is where you really got to think. That x is approaching the asymptote, and the asymptote there is at -2. So x is approaching -2, but which side is it approaching from? Well, it's coming down this railroad track right here, and so it was coming from where the x's were negative, so from the negatives. Then I say it is going towards, it is approaching, and on the y, if I finish this thing and I continue it out, you can see that it is just going down, 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 down. It's going towards negative infinity. On the right side of the vertical asymptote, that'd be that one. And I'd like you all to try that one right now. It's very similar to the left side of the asymptote. And then I'll have the reserve pause the video right here. And then we'll come back and see how you did. It should only take them about 30 seconds. Okay, we're back. Limit of the function as x approaches, well, it was approaching -2 again. But this time it was approaching it from where the positives live. If I show you with some dots here, it was going like that. And it came from where the positives are. So there's a positive there. And then it's headed towards, it's going up, infinity. All right, so there's a quick review of how to do a lot of things with a rational function, including graphing them and doing the limits and the limits near the asymptote. This is going to be the same exact thing on the next few pages. So the first thing you want to do is sketch it. What if it's weird though, like this one? Well, make an XY chart, figure out the asymptotes. What makes the bottom 0? X equals 0. What happens when you put in y is, well, to find the y one, the y asymptote, the horizontal asymptote, you put in 1,000, and then that is pretty much 2 over 1,000, which is pretty much 0. Minus 3 is -3. You find your asymptotes like that, you put in this asymptote on the list, and then you pick a spot on either side, like -1 and 1, and you find some more points, and then you do your limits just like I showed you. All right. For this one, all they're asking is to describe the end behavior as the graph approaches the vertical asymptote using limit notation. So what do you need for these? You need a sketch. This time, I encourage you to just make it a sketch instead of a full-on graph. But I would make a sketch before I tried to figure out the end behaviors. Anytime the teacher wrote it in by hand, you know that this is such an important one that they put it in there on purpose. So I really encourage you to try this. You're going to see factor this, factor that, and then there'll probably be an x plus 1 in it so that it cancels out and makes a whole. Let's do this first one together. So factor this, and then there's x plus 1 on the bottom. You could figure it's probably an x plus 1 on the top, but I'm going to have the teacher pause and then resume it after kids have had a chance to try this. You're trying to find exactly where the whole is an ordered pair. So like something comma something. Okay, we're back. So now you had to have an x here, of course, to make 3x squared. Then you had to have one positive and one negative. And because I think there's going to be a plus 1 in it, I'm going to put the positive there and the negative there. And now I have an 8 and a 1. If I put the 8 here and the 1 here, it's all going to work out. I kind of knew because I needed this x plus 1 to cancel to make the whole. All right, but this does actually factor out properly. This makes negative 8x. This makes positive 3x. Together they make negative 5x, which is what we want. Okay, so I'm going to write the resulting function. After that stuff cancels, I have y equals 3x minus 8. But there was a hole here at negative 1 comma something. So the whole starts with negative 1, and then you stick that in this equation right here. And then you'll have negative 3 minus 8, negative 11. Negative 1, negative 11. Okay, moving on. The algebraic manipulation number 3 review. This is basically the one where you have rationals again, but you're solving them. Okay, so if you might need a second to go on Schoology, find this worksheet. It's the very last one. Basically, it's about, we called it algebraic manipulation number 3, but it's about rational functions and when the functions are inequalities or when they're just solving a rational function. Now this is the last major topic before you're done. So lock in, pay attention here. These were not easy, but it was our most recent test, so I'm hoping that helps. All right, looking at number 1. Is this the kind where you can just clear those fractions? Yes, it is. When it says equals like this, then you can just clear those fractions. That means multiply on both sides by the denominators, and it'll clear. And then this kind just has an answer, or maybe 2. But the other one is, I'm sorry, I got interrupted. Somebody walked in the room, so I'm back with you. I'm going to clear these fractions. When it's like this, when it says like less than, then I have to make the whole number line, and I need to test around it and stuff. But for this kind where it's just equal, then I'm going to multiply on both sides by something to clear my fractions. All right, so I'm going to multiply this one by 2 things. The 2 denominators. I'm going to multiply this part by both things and this part by both things. So the thing I'm going to multiply by first is x minus 2. Do it there, and there, and there. Now this one over here is kind of irrelevant because 0 times anything will make it 0. So that's just going to 0 out. The other denominator we have to multiply by is the x plus 3. So I'm going to do that here, and here, and here. But as I said, multiplying by 0, this whole thing just zeroes out. It's gone. It's still equal to 0. On this one, that cancels that, and I'm left with 2x plus 6. And on this one, that cancels that, and if you can't see it, there was just a little 1 in there. So then that gets times by the x minus 2, and of course I have positive x minus 2. Okay. And this is pretty easy from here. 3x plus 4 equals 0. 3x equals negative 4. X equals negative 4 thirds. But did you even think to look back at the original problem and make sure one of the answers didn't come out to be 2 or -3? Because if they had, they would have been called extraneous. A lot of you got burned on that on your test. You went and solved and found the answer, or maybe there was 2 answers, and one of them turned out to be extraneous, like -3 or 2 would have been in this problem. So always check your answers on these to make sure. So on this one, the first job would be to factor it. That would factor, and surprise, it probably factors to that. Then you'd clear those fractions. And then when you're all said and done, if it's a quadratic, you got to set it equal to 0. And if you can factor it, you should. All right, on to this kind. It's already pre-factored. That's pretty slick. So you got to ask yourself, what makes the top 0? -3 does. What makes the bottom 0? 1 and 7. And some people rack their brains a long time on this, but you can't make that part 0. Even if you put in like a negative number, it gets squared and it turns positive, and you can't make that part 0. So there's nothing to worry about there. There's nothing that's going to make that part 0. Okay, so now my 3 numbers to put on my number line are -3, 1, and 7. So here's -3, here's 1, and here's 7. My 1 got weird looking. I'm going to fix it. Okay, now the top one, this one makes the equation equal 0, but that's not what we want. We want less than 0, so we leave it empty. And the things that make the bottom 0, those just kill the function. They don't make it less than 0. So all of these are empty. None of them are filled in. And now we'd have to test intervals. Like for instance, you'd test 8 and see what it comes out to. And it would make this, if you put an 8 right there, it would make the top positive. And then if I put an 8 here and here and here, it would become positive, positive, and positive. Well, that's all positives. So even when you divide them, you still get a positive, but that's not less than 0, is it? So this place is out. It does not work, because even though it comes out positive, we wanted things that were less than 0 because of that. All right, now we're going to try a number between 1 and 7, like 2. When I put it here, it's still positive. Here, positive. Here, negative. And here, positive. That was positive over positive, negative, positive. There's only one negative in that, but that's enough to make it negative. And those are less than 0, so it worked. Now I should just finish this off and test these last couple. I'm going to put in 0 for this one, and that makes it positive on top over negative, negative, positive. Together, all that is positive. And positive things are not less than 0, so it doesn't work there. My guess is usually then, if it goes kind of every other one, this probably works, but I'm going to check. If I put in a negative on the top, look how I have to square it. Even though it would be negative there, even though it would be a negative, it gets squared, so it's positive. And then it's a negative going in on the bottom, makes it negative and negative here and here. And this one's always positive. Negative, negative, positive. And all told, that is positive. But positive things are not less than 0, so this part does not work. I was expecting it to work. Double checking it. Yeah, those two are negative when I put in -4. So yeah, this one's going to come out positive, which is not less than 0, so it doesn't work there either. So the only spot it worked was between 1 and 7. So that's an example of writing your answer in interval notation. Okay, let's take a look and see if there's any other kinds that are different than this. Not really. There's a lot more factoring to do first, but definitely stuff that's on your final. So look that over, give those a try, check them with the answer key. So on this kind, remember that you'd have to clear the fractions, but I sense that this one probably ends up being a quadratic, and a lot of people would not be careful with that negative there, and it wouldn't distribute it right. You may want to try G if you really want to see if you're good at this. And again, this is one where you'd see what makes the top 0, and there'd be 3 things that would make the top 0. And those would all work because we want things that are greater or equal to 0. So right off the bat, you would know on this one that, let's see, -2 and 3 and 5 would all work because they make the top part 0, so that makes the whole equation 0. Then on the bottom, there is one more thing, and that's +1. And +1 does not work because it would kill your function. It would not make it bigger than or equal to 0. It would have a 0 on the bottom, so you leave it empty. And then you'd test all the intervals around that. Okay. We didn't do problems like this, so don't worry about that. Same with this. And yeah, this pretty much means we've done it. So what do you do? My advice to you is to go and now practice anything that needs extra help. And I've made a video now for every single part of the first semester, so you can go back and watch those. Study up because the final is not going to be easy, but it is Marzano graded. So remember that means if you can get 75% on the R2s and 75% on the R3s, you'll get yourself an A. All right, good luck on your final. I'll be rooting for you.